So today we are continuing what we kind of where we left off in our last lesson, solving quadratic equations. Our goal is still the same, find those two solutions. But now we're going to run into a bit of a roadblock in the case that, what happens if we just can't factor something? Because the only method we've learned so far was yesterday, and that was assuming that we had something that we could factor, whether it was a greatest common factor. We used the asterisk method. There's potential it could have been a difference of perfect squares. We didn't have any on the assignment yesterday, but could be, factored by grouping. We have lots of ways of factoring, but that doesn't guarantee that everything can indeed be factored. So we're going to take a look at a quick example here. We're going to pretend briefly that this is a quadratic equation. And I know the context around it says that, yes, it's unfactorable, but I want to see it. I want to see what it looks like. How far do we get before we realize I can't use this process? So going into our mindset from yesterday, first thing I want to happen is what? A 0 on one side. So we want the equation set equal to 0. So that's done for us conveniently. Then we're going to try to factor it. So what do we always check for first? Always check for a greatest common factor. And if it helps, if you need to see it, there is a -1 next to this k. But I don't believe there's a greatest common factor because of it.
They all three don't have k's.
Okay, so all three of them don't have at least 1k, so we can't take any variables away. And I would say, well, one doesn't have any smaller factors or bigger factors than 1. 2 and 5 are both prime. We're pretty dead in the water there in terms of greatest common factor. But that's okay. We're pretending for a moment that we can just keep pursuing this problem. Next thing I would probably notice that this is a quadratic trinomial, which makes me think asterisk method. So worth a shot. So since we've considered the greatest common factor and there was none, what's my A in this case? 2. What's my B? A -1, and a C is -5. So off to the right here, I'm going to draw in an asterisk. So A times C is going to go on top. We're looking at 2 times -5, which is -10. A on either side are 2's. B on the bottom is -1. So I'm going to wait for a moment, give you about 30 seconds. If you have your factor pair list, pull that out, look at your factor pairs for 10. Thankfully, it's not a very long list, so it's not going to take you too long to take a look at it. But I want two numbers that multiply to equal -10, but at the same time add to equal -1. So you're putting your foot down, you're saying it doesn't happen, can't happen? Well, like I said, the list for factors of 10 is very short. You have 1 times 10, you have 2 times 5. Well, if we think about it, if you add 1 and 10, they have a sum of 11. They have a difference of 9. So those, no matter what I do with the signs, that one's not going to work. So then I think about 2 times 5. Well, if I add them together, I get 7. They have a difference of 3. So again, no matter how long I play with those signs, making one positive, one negative, both negative, what have you, there's no way I can get a 1 out of it. So even though so far, we didn't notice until this point that it couldn't be factored, we've hit a wall and we've considered every option. Thankfully, there weren't too many. But at this point, we have to say that it's unfactorable. Now, yesterday, if we hit a situation like this, which very intentionally you did not, yesterday we would have then said, well, this is unsolvable. And that would have been true, except today I'm going to show you that there's another method that allows you to continue solving these types of equations even when factoring fails. Now, what I would say is, unless it states a specific method to use, always try factoring first. You know, always set it equal to 0, try to factor it, whether it's greatest common factor, asterisk method, what have you. Because if it factors, great, you can save yourself a little bit of time, save yourself a few steps, no big deal. Worst case scenario, if it doesn't factor, you're already going to already have it set up in the form you need for this new method I'm about to show you. So in comes the quadratic formula. Now, a lot of students find this very intimidating because it is very busy at first, but when you find a very systematic way of going through it, it becomes very routine very quickly. So if factoring cannot be done, there's always a backup for solving quadratic equations using what's called the quadratic formula. Again, notice quadratic, meaning that if it was any degree higher than 2 or lower than 2, would this apply? No. So it does still have to be quadratic. But if it is quadratic, we would apply this formula. It must be in descending order and set equal to 0. So like I said, go ahead and try factoring, because if it doesn't work, then you've already got it in descending order and set equal to 0. You're ready to start to pull out the pieces. Because if you take a look at this rather intimidating formula, it is x equals, or whatever variable, this letter here could change based upon your equation. Whatever variable you're solving for will equal negative b plus or minus. We'll talk about that here in just a little bit. The square root, which we've dabbled with a little bit. I'm not going to go into too much detail with it. I am going to show you, though, on the calculator how to calculate square roots. So plus or minus the square root of b squared minus 4ac, the entire thing over 2 times a. Now, where do you think the a, b, and c are going to come from? Close. Not from the asterisk specifically, but it's going to be the same a, b, and c we would have used in the asterisk method. So that is, again, why it's so important that it's in descending order and set equal to 0. That's where we're going to find those values. Now, here's the good news. I'm not going to expect you to memorize this. Now, you may accidentally do it, depending on how many times you use it. But this is definitely a formula I would give you in order to solve an equation like this. And on the test, for which we start our review tomorrow, on the test, there's 3 problems. And you'll see why there's only 3 problems. It takes a bit of work, and it's important to be neat and organized. But without further ado, let's just jump into it. So same equation that we tried factoring earlier. It's already set equal to 0. We know it won't factor. It's already in descending order. If you want to see that -1 there hiding again, go ahead, draw it in. That's fine too. But you're going to notice we're going to use the same a, b, and c we did before. I think I'm going to write mine. How much space did I give myself? Oh, plenty. What's a? 2. B is a -1. C is -5. Now, again, these are the numbers that we're going to use in the quadratic formula, similar to how we use them in the asterisk method. But we're going to, one at a time, go through the quadratic formula. And when we hit a variable A, B, or C, we're going to pluck just that letter out. We're going to drop in one of these values, but we're going to wrap them in parentheses so that our eyes can see that this has been a change. This is something that we've brought in. So this time our variable is the letter K. So I'm going to have K equals negative B, but what's my B? -1. Now notice this negative sign is part of the formula. There will always be a negative sign there. Your B will not always be negative, but in this case it is. Plus or minus the square root of b, which is -1 still. Notice that I wrapped it in parentheses, and I'm going to put the exponent of 2 outside because it was part of the formula as well. Did it? Son of a gun. It froze. All right. Minor technical difficulties, but we're back on track. So we had -b plus or minus the square root of b squared minus 4. This -4 will always be there. That's part of the formula. Times a, which is 2, times c, which is -5. Notice I wrapped each of them in their own set of parentheses. Then big old fraction bar. The entire thing is over 2. That 2 will always be there. Times a, which this time is also 2. Now, if you're a very visual person, which I personally am, and you're still not quite seeing where everything came from, again, this is not required, but I'm going to do it for this first one so your eyes can kind of adjust. The A went right here and right here. The B dropped right here and right here. And the C went right there. Now notice, if I didn't highlight it, so like the negative sign right here, the plus or minus, the square root, the exponent of 2, the -4, fraction bar, and the 2, those will always be there every single time. Now, what we bring in for the A, B, and C obviously will change what we do with those values. But those pieces I haven't highlighted, those are there every single time. What's in the parentheses, those are the only things that have changed. Now, as I mentioned it earlier, it looks like we created a bigger mess than what we started with. There's all sorts of parentheses. It's a lot going on, but very quickly, if we go through kind of left to right, top to bottom, like we're reading a book, and address each set of parentheses individually, we're going to clean this up rather quickly. So in my next step, I'm going to still have k equals, I'm going to start here at the top, -1. What's that going to become? +1. Plus or minus, we're not ready to talk about that yet, so bring it along. Square root of what's -1 squared? In other words, -1 times -1. +1. And then here, technically, we're going to do 2 multiplications simultaneously. What is -4 times 2? -8. Take that -8 times -5. +40. And then this entire thing is over 2 times 2, which is 4. So already by the second step, very quickly, we're down to just what? 1, 2, 3, 4 values. Not too bad. Started off scary, but it's cleaning up nicely. But then I look here, there are some new pieces. That plus or minus, which again, we're not quite ready for. That's usually one of the last things we take care of. But we do have this square root. Now, at this point, I would say if you were to refer all the way back to day 1 in our notes, we talked about order of operations. And in the order of operations, I said P is parentheses, but really it should be grouping symbols. And I listed parentheses, brackets, braces, and radicals. That's what the square root sign is. So if I'm still following the order of operations, could I just go ahead and add the 1 plus 40 inside that square root? It's like a set of parentheses. It's grouping the 1 and the 40 together. Might as well, whatever I can combine, I might as well combine. So I'm going to take one more step here and say k equals 1 plus or minus the square root of 41. Now, I'm going to pause there for a moment because at this point, we're going to learn two different paths. With me, we're going to learn, with the help of a calculator, how to approximate our solutions. Now, next door, when you're moving on to Algebra 2, she's going to teach you how to solve these exactly. Now, those answers look a little bit scarier, and it requires a few additional skills. But you will revisit this again in Algebra 2. And it's at this step that you'll take a different route. For us today, though, we want to keep pursuing this because we're going to say we're going to round because close is going to be close enough. Here's the problem, though. We still have that square root there. And off the top of my head, I don't know what the square root of 41 is. And some of us may not necessarily know what the square root does. So if you have a calculator handy, go ahead and grab that. If you'd like to grab one of mine, please go ahead and do so. What I'd like you to do is I'm going to, instead of the 41, let's do a couple values that I think will work out quite nicely. Real quick for me, take the square root of 25. 5. What about the square root of 81? Square root of 100? Square root of 4? Square root of 9? Square root of 36? Now, are you doing the calculator, or some of you seem to be doing it without the calculator? What does the square root do?
It's whatever times like this times this equals that. So it's the same number twice, like 3 times 3.
So in essence, it tells you what number multiplied by itself makes the original number. So right, so square root of 100 tells me 10. What that means is 10 times 10, or 10 squared, makes 100. Now, we'll spend some time next week talking about square roots in a little bit more detail. But square roots, for now, we could just think of them as kind of figuring out what squared equals the number inside. Here's the problem, though. 41, square root of 41. Does anyone know that off the top of their head? I'm seeing some head shakes. No. Why not? It's not a perfect square. And we've talked about perfect squares last week. When we talked about the difference of perfect squares, we listed the first 10. 1, 4, 9. Oh, shoot. 16, 25, 36, 49, 64, 81, 100. And that list goes on forever. 5 squared would make 25, but you can't make 5 because it goes from 4 to 9. So 41 is not a perfect square, which is why we're going to have to rely on our calculator today, because at this point, I can't continue what I know, because the square root of 41, being in a square root, will not behave like numbers that we're used to. So we're going to grab our calculator real quick, and off to the side here, we're going to approximate the square root of 41. And I'm going to suggest we go out 2 decimal places. That's usually accurate enough. And I'm going to use another symbol, which is probably new. Looks like a curly little equal sign, if the screen delay catches up. So that little squiggly equal sign means we're about to round here. This is an approximation. So in the calculator, please, what is the square root of 41? We're going to go out 2 decimal places. 6.40. Someone else also, because it's always good to check each other. How do you do square root? What calculator are you using? One of mine? So I think mine does it backwards. I think you have to type in 41 and then press the square root button. I think. 6.403. Okay, so it would round to 6.40. Thank you, everyone, for calculating that. So what this is going to allow me to do now is knowing that the square root of 41 is approximately 6.40, it's going to allow me to replace the square root of 41. So there's also another adjustment here. Are we dealing with exact answers anymore? No. The moment you round once, the rest of your steps are now approximations. So I like to make a minor adjustment. A lot of people don't do this, but I like to use it as a reminder that, oh, I'm approximating now. I change out my equal sign for that approximate symbol. So K is approximately 1 plus or minus, instead of the square root of 41, what are we putting in its place? 6.40. Notice the square root is gone as well. We already used it up. If you put that button in the calculator, it is used, it is gone. I have some students still leave it in there. They pull out the 41, they put in the 6.40. It's gone. We used it up. This is all still over 4. So good news is we got rid of one new symbol, but what's still kind of strange? The plus or minus. That's a bit new. But here's the cool thing that it does. Yesterday, when you were solving the quadratic equations by factoring, on average, you typically got how many answers? 2. Well, I'm suspecting that that trend should continue if quadratic equations usually have 2 solutions. Guess how many bits of work are hidden in this, this formula because of that plus or minus? There's actually 2 things we can calculate here. So
It's kind of like how we could have done negative positive numbers for the asterisk thing yesterday.
that's a good way of looking at it. Because of the potential in the asterisk method of having positive or negative values, the positive or negative is taken into account here with this plus or minus sign. So on a little side note here, so we'll say after the square root we can split at the plus or minus sign. Gotta beautify my notes here. You know me. So again, it started off as a crazy mess. We cleaned up the parentheses, simplified inside the square root, grabbed a calculator, approximated the square root, and now that we have just 3 values, we're ready to split at that plus or minus. It's done, being efficient. It was allowing us to not have to do 2 sets of work all the way through. It was allowing us to go through just 1 set of work, but now it's time to break apart. So we're going to have 2 things here. Either K is approximately 1 plus 6.40 all over 4, or K is approximately 1 minus 6.40 over 4. Notice the only difference between the 2 of them is where the plus or minus was. One of them is now the plus, one of them is now the minus. All that's left is to finish solving each of these. I usually go down one of them all the way before switching to the other. So on the left, what's 1 plus 6.40? Oh, that would be, it should be 7.40. And then you may have to grab a calculator for this. That's okay. What is 7.40 divided by 4? 1.85. Okay. On the right, what is 1 minus 6.40? Almost. negative 5.40. And when you divide negative 5.40 by 4, negative 1.35. Well, you have $1 in your bank account and you lose $6.40. You've overdrawn your bank account. So that's why it's very important where we put the symbols. The plus or minus means we're affecting the second value. Yeah, the 1 doesn't change in either. 1 is positive in both scenarios. Now, with a little bit of work, we just came up with the two solutions that are approximately 1.85 and negative 1.35. Oof. Now, the fact that we had to approximate very quickly tells me that's probably why it didn't factor. The solutions themselves were very long irrational numbers. Irrational means, think back to when you put in the square root of 41, that decimal goes on forever and it never repeats. So it's just never ending. But with a little bit of work, we found two very approximate answers, but closest, fairly close in this situation. It just took a bit of work to get there. Now, if you're systematic about it, if you're not rushed, if you're writing neatly, you're going to have essentially the same exact number of steps every single time. The only difference is the values you're working through. This process is very repetitive, which is why I don't even think I gave you that many examples today. 16. And if you only do half like I usually assign, that means only 8. Because it is very repetitive. And in my opinion, if you can do 8 of them, you could probably do 16. You could probably do 1,000, which would be extremely boring. But there you have it. Bit unusual. We had to rely on our calculator to be able to approximate the square root of something. And we also had to figure out what this weird plus or minus sign allowed us to do. Turns out it was really just a shortcut, saved us some steps along the way to about halfway through the problem, at which point we split it apart and it allowed us to find our two separate answers. Now, I'm going to practice a couple more. So onto the back side here. First off, I'm going to split up my workspace here. See, about halfway. See how consistently I can write. So we have two more quadratic equations to solve. I will save you the hassle of testing the theory. These do not factor. So we're going strictly quadratic formula here. What is the problem with this next one?
It's not zero.
Doesn't have 0 on one side, so it's not set equal to 0. And then obviously that also means it's not in descending order. So we have a little adjustment to do. So not set equal to 0. I'm gonna set up a little guideline there. That way I can see one side apart from the other. What would you recommend we move to get it set equal to 0? I would agree. I'd like to move as few pieces as possible. How would you move that 4v off of the right-hand side? Subtract it. Now, whatever you do on one side, you have to do it to the other. But are there any like terms on the left-hand side? Well, we have a v squared, and we're moving a v term. So unfortunately, there's not. But if I'm kind of thinking ahead, I do want it in descending order. So will the minus 4v be the first, second, or third expression or third term in the expression on the left? The second. So kind of somewhere between these two. Okay. So I'll do the right-hand side first. That's kind of what we're really interested in. 4v, take away 4v is going to give me 0. On the left, writing them in descending order, can't combine anything because there are no like terms. I'm going to end up with 11v squared minus 4v minus 23. Now, like I said, it doesn't factor. We're not going to waste our time with the asterisk method here. We're jumping straight to the quadratic formula. But remember, we use the same A, B, and C anyways. So I'm going to actually write mine off to the right here so I have more space down below. What's my A? 11. What's my B now that I fixed it? -4. And what's my C? -23. Okay. So we have our values. Somewhere you have the quadratic formula written down. Some of you probably already copied it over to the back side, which is a good tool to have. We're ready to drop in the A, B, and C exactly into their corresponding locations in the quadratic formula. This time, the variable we're solving for is the letter V. So I'm going to have V equals negative B, which is what? -4, plus or minus the square root of B, which is still -4, squared, -4 times A, which is 11, times C, which is -23. The entire thing over 2 times A, which is still 11. Now, if you want them color coded, if it helps you check to see that they're in the correct locations, by all means, you're welcome to do so. I even have highlighters if you'd like to do that. But if I were to go through this with the formula right next to it, I would see that I have negative B plus or minus the square root of B squared minus 4AC all over 2A. Just a matter of matching. Here's the more exciting news. On the test, each of these 3 problems that I test you on are worth 4 points apiece. You get 2 of those 4 points, so half the points if you simply drop them in the correct location. And that's just because it requires organization. That's half the work right there. Now, once you get them in the right location, we're not done. We got to start cleaning it up one set of parentheses at a time. So I'm going to get V equals, what's -4? +4. Plus or minus the square root of what's -4 squared? +16. Remember, the parentheses wrapping around it makes the difference. This is -4 times -4. So we get a +16. Next one, I would grab a calculator here. -4 times 11, almost. -44. You're okay. I'm only picking on you because those signs, one little sign out of place is enough to cause a headache. So -44 times a -23, 1012. Okay. Double check. Make sure. Here's what I suggest. Because we're doing this as a team, use each other to rely on each other. Does everyone else get 1012?
Yeah.
Okay. 2 confirmed. Good. The entire thing is over 2 times 11, which is 22. Is there anything else we can simplify? The 16 and the 1012, they're both grouped inside the square root. We can go ahead and combine those. And we will get 4 plus or minus the square root of what? 1028. The entire thing is still over 22. Now, I don't know my perfect squares that far. So maybe if we're lucky, it's a perfect square. I doubt it though, because if it was, then it probably could have been factored. But again, just making a mental note here, we're going to use our calculator again. And I'm looking to approximate the square root of 1028. What do you guys get? 32.06. Okay.
That's 22 divided by 1,000.
The 1028.
Yeah.
So we're not dividing it, we're taking the square root of it. So often that's actually a common mistake. Sometimes students think taking the square root is the same as finding half of it. It's not quite the same. Actually, not at all the same.
I think it's the line. It's not-
Gotcha. So now that we have the approximate value for the square root of 1028, I can go back to where we were at and I can replace the square root of 1028 with that 32.06 we found. So V is approximately 4 plus or minus, not the square root, 4 plus or minus 32.06 all over 22. With that approximation now, what can I do? Split them apart. Where at? Where am I doing the split at? So at that plus or minus, that's the change. So we'll say split at the plus or minus. So Sean said B is approximately 4 plus 32.06 divided by 22. Or B is approximately 4 minus 32.06 divided by 22. Once we get to the split, then it's just a matter of some quick arithmetic. Calculator would be a good thing to kind of help us through here. So if I start here on the left, what's 4 plus 32.06? And then when you divide that by the 22, 1.63. Okay. Transitioning to the right here, what's 4 minus 32.06?
28.06.
Almost.
Negative.
Negative 28.06. And then when you divide that negative 28.06 by 22, negative 1.27. Good. So our two solutions are 1.63 and negative 1.27. There's that one. Again, if you were to set these side by side, this one with the previous one, aside from the fact that we had one little extra step at the beginning, we needed it set equal to 0 first. All the other steps are nearly identical. The only thing that have changed are the values along the way. So I'll leave that there for just a second in case anyone's still jotting it down. If we do move on and you still need something to write down, I can always bring this back up later as well. So while you guys are still jotting it down, at no point will I try to sugarcoat this. It's not the most exciting thing. It does take a lot of work. I won't argue with you on that. I would, in fact, completely agree with you. What I will say, though, in terms of difficulty, probably not the hardest thing we do. It just looks scary at first, because if you were to come in right now and I were to say, take a look at this problem we just solved, and you had no context, you just walked in, have never seen one of these before, I would say, yikes. But when you do multiple ones of these, you'd be like, wow, it's literally the same steps over and over and over again. All you want to make sure you're very careful on are your values, particularly the signs. If you're going to miss anything, you're going to miss a sign. All right, let's take a look at the second one here. Right off the bat, what is my concern? No zero on one side. So we've got some adjustments we got to make here. What would you like to move? The 4 and the 5? Interesting. It's not what I would have picked, but we can go that route. So you want the 0 on the left-hand side? Okay. So on the left, how would you move that 5x squared? Minus the 5x squared. Is there a like term to subtract it from on the right? Okay. So I'm going to line those two up nice and neat. Simultaneously, to save myself some space, how would I also move the negative 4x? Close. It would just plus 4x. Now, is there a like term to combine it with on the right? No. So we'll want to be careful as we go through. Don't accidentally combine things that don't belong together. So on the left, 5x squared minus 5x squared is gone, equals 0. Negative 4x plus 4x also gone, gives me 0. So on the left-hand side, I have 0 equals. On the right, what's negative 5x squared minus 5x squared? Almost. Like terms, don't touch the exponents. It's only multiplication or division that the exponents will change. So we get negative 10x squared. Then when I look at the next two, I have 2 and 4x. Now we can already agree they're not like terms, but which one do you think I would want next? That 4x. Because remember, we want it in descending order, which means the last term would be that plus 2 there at the end. Now, if you want to try factoring it, great. Some of you may even say, well, there's a greatest common factor there. Yep. But I'm not solving by factoring, so I'm not even going to bother with the greatest common factor. I'm just going to go ahead and pull out the A, B, and C now so I can start dropping them into the quadratic formula. So in this case, the way we've got it written, what's our A? Negative 10. What's our B? Positive 4. And our C? Positive 2. Now, some of you might be thinking, because sometimes I have students do things a little bit differently, and I don't want you to be discouraged by that. Some of you might have said, well, I would have moved the negative 5x squared and the positive 2, and now all my signs, I have the same values, but they're the exact opposite signs. That's okay. So long as you're careful with your signs through this entire process, they will still work out to be the same values. Now, if we had extra time, I would work through this problem both ways, but let's face it, you're already bored. We'll just do it once. So with those values, be mindful of the signs. We're going to use the quadratic formula now to write x equals negative of b, which is 4, plus or minus the square root of b, which is still 4, squared, minus 4 times a, which is negative 10, times c, which is positive 2. And then the whole thing is over 2 times a, which is a negative 10. Give you a moment to digest that or write it down. Take as long as you need. Again, be very mindful of the signs. If it's outside the parentheses, it should have already been there from the formula. If it's inside the parentheses, those are the pieces we dragged in. Now, once you have those pieces in place, we're going to go through one set of parentheses at a time, cleaning them up as we go. So I'm going to have x equals negative of 4. What's that become? Negative 4 plus or minus the square root of 4 squared.
You said x equals -4.
Yes. So that very first one, you can think of that as negative 1 times 4. That's correct. The 4 squared gives us 16. And then the little 3-number multiplication, negative 4 times negative 10, positive 40. Positive 40 times 2 is positive 80. All of this is over 2 times negative 10, which is negative 20. Still have some simplifying we can do inside that square root. So I'm going to get x equals negative 4 plus or minus the square root of what? 96. Because I can't use my calculator until there's just one value inside. So negative 4 plus or minus the square root of 96 all over negative 20. And then at this point, we say, okay, calculator, help me out. Approximating the square root of 96, 9.79. What's the third decimal? Oh, 7. So technically then the 9 would round up to 10, which technically brings, so if we're being sticklers for rounding, technically this 0.79 would round up to 0.8.
Did you kind of solve for that?
No. Now, if you were an astronaut and your calculations are going to affect my success of reentry and life, yeah, I'm going to count against you. But in this case, 2 decimal places out, your eyes can't tell the difference between 1/100th of an inch. So probably close enough here. All right, so when I get to the square root of 96, I'm going to swap that out with the 9.80. So we can now say that x is approximately negative 4 plus or minus 9.80 all over negative 20. Now that we've approximated the square root, we're ready to split at the plus or minus. So our 2 resulting equations will say that x is approximately negative 4 plus 9.80 all over negative 20, or x is approximately negative 4 minus 9.80 all over negative 20. So starting here on the left, oh, I'm getting close on space. Negative 4 plus 9.80, I believe is 5.80. And if you divide that by negative 20, sorry, I want to make sure that seems 2 times 8. Yeah. Divide that by negative 20. I know it's negative.
got -3.448. I really by experience, my beliefs of what buttons to push first.
So something, this should be a really small decimal, I believe. So 5.80, then divide. If you're using one of my calculators, you have to press 20.
Oh, I forgot how to do it.
Put -20 first and divided that by 5.
Always the top before the bottom. So if I were to grab my calculator here, 5.80 divided by -20, I'm getting -0.29. If you still can't get that answer, talk to me. Let me see what calculator you're using and we'll walk through the process. Because frustratingly enough, every calculator usually is just a little bit different. Going to the right-hand side here, -4 minus 9.80, I believe is -13.80. And when you divide that by -20, I know it's positive. 0.69. Good. So our two answers were -0.29 and positive 0.69.
Calculator class.
Do what?
Well, calculator class. I have avoided calculator my entire life because I was so set on just like learning
Mhm.
it and not having to rely on it.
So I respect that, and I respect learning the mental math or how to do it on paper. That is a terrific skill to have. But at the same time, also knowing how to work with the calculator, or technically, I should say, make the calculator work for you. Is a great skill, especially when you start to get into these types of problems. So take a look. It's not perfect, but do you see how my steps are almost identical from one problem to the next? Now yours won't be that perfect because I've just practiced a lot. I've done these so many times. But here's a clue, or not clue. Here's some advice. Knowing the amount of work, the amount of detail that is important here, the amount of space provided on the actual worksheet itself will probably not be enough for you. Which is why I would like to point out that I have lined paper. I even have grid paper if you prefer that. Up on that front table, I would rather you use as many pages as necessary to write these steps out completely than try to take shortcuts to fit it into a small cramped space. But there you have it. Now, wouldn't be a math class if there wasn't an exception, right? So kind of spoiled the surprise here. This one says no solution. And it says occasionally quadratic equations have no real solutions. And you reach this conclusion when you hit an error while using the quadratic formula. But I'm not going to tell you when. I want to experience it for ourselves. So for a moment, we're going to use our imagination yet again and pretend like we don't know that this one's going to give us no real solutions. We're just going to go about solving it as we would any other problem. And right off the bat, what's our first issue? There's no zero. It's not set equal to 0. We could subtract 5 from both sides. Is there a like term from the left? We can subtract it from the 13. Sounds good. So bringing everything down here, we should have 9x squared plus 4x. 13 take away 5. What's that? 8? Equals 5 minus 5 is 0. There's that 0 I like to see. Again, we can pull out our A, B, and C. So what's my A? My B? So A is 9, B is 4. My C is 8. Okay. So again, so far we're just oblivious to what's going on. We're just solving it like we've done the previous 3. So we're going to have x equals negative b, so we'll have negative of 4, plus or minus the square root of b, bless you, which is 4 squared, minus 4 times a, which is 9, times c, which is 8. All of this over 2 times a, so 2 times 9. Anything alarming yet? Seems pretty normal. Okay. So we just keep going. Cleaning up these parentheses, negative of 4. What's that give me? Just negative 4. Plus or minus the square root of 4 squared, which is 16. And then here we may grab our calculator. Negative 4 times 9. I believe it's
36.
negative 36. Take that negative 36 times 8. Negative 288. All of this is over 2 times 9, which gives us 18. Anything alarming yet? Still seems pretty normal. So we'll keep going. Let's go ahead and simplify what's inside the square root. So we'll have negative 4 plus or minus the square root of 16 minus 288.
272.
Positive or negative?
Negative.
So negative 272 over 18. Oh, hold on.
Having a stroke?
So over 18. Okay, anything alarming yet? I'm seeing a few head nods because maybe you noticed something a little bit different, but technically, have we broken anything yet?
Just my brain.
Not yet, maybe in our brain. So let's say for a moment, everything seems okay so far. So technically at this point, we would approximate, is that right?
Yeah.
So we'd say, okay, calculator. We want to know the approximate value for the square root of negative 272. What do you mean there isn't one? Put in your calculator. It says not a number.
Doesn't give me anything.
It gives you nothing.
Mine gives me an undefined answer.
Okay, I know it's.
Like it says undefined.
Yeah.
Okay, I know based on
Cannot
context,
show
like, there's nothing
undefined
there,
result.
but how do I actually put it in? Do I put
That's what it's telling me.
negative 272 and then the square root button?
So if you're having troubles putting it in right now, depending on your calculator, if you're using one of my classroom set, then you're going to put the 272 in first. You're going to make it negative. Then you're going to take the square root of it.
You get the minus a.
So regardless of what calculator you have, it's going to come up with some sort of issue, which I'm just going to summarize as saying error. Any ideas why? What was different about this one? It was the negative. What we were trying to take the square root of was a negative value.
So we haven't had any negative square roots up until now.
So what we can basically say to summarize is we cannot take a square root of a negative value. And technically, I should tell you, can't take the square root of a negative value yet. Now, for our purposes, though, because this is where Algebra 1 is going to kind of leave us off, what we're left being able to say is that this one has no real solutions. Now, emphasis, don't just say no solutions. You have to say no real solutions. Guess what that means?
Can't be twice.
It's not unsolvable, it's just unsolvable right now. There's no real solutions. Guess what that means? There are solutions, they're just,
Kind of like if you're doing a word problem, if you got a negative answer, it still would work. but
so
in this scenario, that would not.
a similar situation. Yeah, that's a good way to tie it in. Similar to the word problems that we found two answers, only one would work. But in this case, our two solutions that do exist are imaginary,
I'm not saying-
which sounds like we're in make-believe land. But when you get to algebra 2, you will learn an entire new set of values, new set of numbers called the imaginary numbers, which exist separate from all the other numbers that we have learned so far. Now, what they allow you to do is solve problems that are otherwise, for a moment, unsolvable. They get you over that hurdle, they get you back to where you need to be, and then you can still perform different math functions on them. For now, though, in our world, in the world of Algebra 1, calculator said, nope, can't take the square root of it. We're just going to take it for face value. You will, though, learn in Algebra 2 that there are ways around this that your calculator cannot help you with. So if you hit an error, if you try to take the square root of a negative value today, and it says, nope, can't do it, write no real solutions, and that one is done. I think there's like one, maybe two thrown in on the assignment today.